Welcome to Brain Vision.
Hi everyone, so what we have here is we have a nozzle in which steam is flowing through. The steam enters the nozzle at a pressure of 200 kPa and a temperature of 50 degrees C, and leaves the nozzle at a pressure of 75 kPa as a saturated vapor. We do know that the steam loses heat at an amount of 26 kilojoules per kilogram, and what we're asked to find is the exit velocity and the mass flow rate if we know the exit area to be 0.001 meters squared. So what we're going to do first is just go ahead and write down our assumptions. So we are going to assume that this is a steady state process and nothing is going to be changing with time. We're also going to assume that any changes in potential energy are negligible, and we're also going to assume that there is no work that's occurring in this process. So we're actually going to define our system, and we're going to take the steam to be our system, and we're going to do our energy balance here. So we know that the energy coming in minus the energy coming out is going to be equal to the change in rate energy of our system. As we said before, this is a steady state problem, so this will be equal to 0. So we can go ahead and say E dot in is equal to E dot out. And we can go ahead and break this down into its constituents and say that m dot h1 plus v1 squared, so this is basically the enthalpy plus the kinetic energy coming in, is equal to m dot h2 plus v2 squared all over 2 plus q dot out. And this is the enthalpy leaving, the kinetic energy leaving, and the heat that is being transferred out of the steam. And what we can do, as you can see, is that m dot is constant because q dot actually is just m dot times that q that was defined earlier in the problem. So what we can see here is that we are left with h1 plus v1 squared all over 2 is equal to h2 plus v2 squared all over 2 plus small q. And we can actually solve this expression for v2, and what we get is that v2 is equal to 2 times h1 minus h2 minus q. Next, what we can do is find the properties of our steam at the inlet and exit in table A-6. So for the state defined by the inlet at P1 equal to 200 kPa and T1 equal to 150 degrees C, we see that the incoming enthalpy is 2,769.1 kilojoules per kilogram. And at our exit, we know that P2 is 75 kPa, and we are also given that it exits as a saturated vapor. Therefore, we know that the exiting specific volume is going to be equal to 2.2172 meters cubed per kilogram, and the exiting enthalpy will be 2662.4 kilojoules per kilogram. We can actually go ahead and substitute these quantities into our expression for velocity, which was equal to 2 times h1 minus h2 minus q. So by plugging in all of those quantities we got from the table and the problem statement in, we'll see that we have an exit velocity equal to 401.7 meters per second. So that is one part of our final answer. Remember that we're also looking for the mass flow rate through the system as well. So m dot is equal to rho UA. Remember that we can rewrite rho as equal to 1 over specific volume. So we can write this as 1 over V2 A2 V2. And by plugging in for these quantities, we'll see that the final mass flow rate is going to be equal to 0.181 kilograms per second. And that's our final answer.